Welcome to today's webinar. Today we're going to focus a little bit more on the sources of data on the mainframe going to, a myriad of targets that we support. There's previous webinars and deep dives into PropelZ that really talk about the targets, and we'll address that in a very summary fashion here today. But really we're going to focus on diverse data sources on the mainframe side and what we can do with that and from the PropelZ perspective. So I am Dustin Froyum. I'm one of the co-founders of VirtualZ, and along with me co-presenting is Vince Ray, our CTO and co-founder as well. Good morning, Vince.
Oh, good morning. Good to be here today, and thanks to everyone on the call for joining us.
And then we'll talk a little bit about the challenge of legacy ETL, and then we'll dive into PropelZ and Q&A, and we'll get out of here. So, for those that have been around the mainframe for a while or decades, like probably several of us on the call, this isn't going to be new news, right? You had legacy ETL processes to get data out of the mainframe that were built by necessity, right? There wasn't necessarily commercial products when ETL first started, or they're more complex, less automated. And so there's some challenges that come with that, right? The talent shortage, the cost of maintaining those custom solutions, or even more complex solutions on the market, like change data capture, which can be very fragile and difficult to even implement besides maintaining it. So those are huge problems. And then as we move into really this period of AI and data lakes and BI, wherever all the data wants to be integrated, how do you do that in a very no-code, automated fashion, and do that in a very up-to-date way, right? Near real time, in some cases real time, for monitoring like alerts or security things. So we'll get into that as well. So today we're going to focus on our PropelZ product and the solutions that brings. So I'll just cover very briefly. So PropelZ, we can multiplex to a ton of different targets, and we do this through using JDBC as the implementation. And this actually has multiplexing capability, so we can go to multiple clouds or multiple targets at the same time. And this is again, a very no-code fashion. We ship with 5 JDBC drivers that are tested and optimized with PropelZ out of the box. MySQL, Azure SQL, let's see, this is my test, Vince. Postgres, Oracle, and now I gotta remember I'm missing one. Postgres, Oracle, MySQL, SQL. Which one am I missing, Vince?
Oh, what are you missing? MySQL, Oracle, Microsoft SQL Server, Snowflake.
Oh, Snowflake. I was missing Snowflake.
Snowflake.
So, yeah, so we ship those out of the box, but we're happy to test and optimized additional drivers. We have access to proprietary drivers, or we can always look at open source drivers as well. So again, this is completely no code. PropelZ sits on the mainframe, includes our data transformation engine, so we can put that data in a blob or untransformed, or we can transform that data as well into rows and columns of that database. So Vince, here's where I'm going to call upon you. So maybe a little bit deeper into our 3-part architecture, and let's start with database and file sources capabilities, and then we'll talk a little bit about our real-time streaming abilities.
Yeah, and I think that's a helpful thing to explain. PropelZ is really 3 major parts, building blocks that kind of together form the PropelZ service. And you could think of it as kind of an input stage, processing stage, and an output stage. The input stage really is, the most common thing is it's going to be a file. It's going to be a VSAM file, whatever you might have. But it could be anything. any data you can materialize on the mainframe can be piped into PropelZ, and you can use virtually any source of data for that. It could be real-time data, could be different types of databases. It could be files. I mean, much easier to just point to a file and say, "There's my input." But pretty much no matter what you have, the output of an existing transaction could be fed into PropelZ. The output of a batch job, really anything you can imagine can go into PropelZ. The processing piece is mostly about how we transform the data into the formats that the source, or the target, really, it's what the source gives you and what the target expects are often very different. So an example of that, the source is a VSAM file and the target is a relational database. That data might need to be broken out into rows and columns. That all goes on in the processing stage. And really the big tool there is PropelZ includes a pretty robust data transformation engine. So you can give us a little bit of metadata that describes what your inputs look like. And then we can use that to transform those input records into whatever form is needed. If the output is going to be a database, that's pretty straightforward. It's rows and columns, SQL, all of those kind of things. But, let's say you wanted to, I don't know, push that data out over an API of some sort. In that case, you might want that record to be transformed to a JSON object or an XML object, or some other format, whatever you might need there. That's what goes on in the processing stage. And then finally, the last stage is the output stage. And Dusty mentioned the popular one is JDBC. JDBC allows us to talk to pretty much any target database out there. It could be a SQL database, like the 5 we were struggling to remember. It could be a NoSQL database, MongoDB, or whatever you might have. There are plenty of things that support JDBC, and there are even some things that are basically using JDBC as just kind of a thin layer over an API. Our friends at Salesforce.com, for instance, do that. I can push data to something that looks like a JDBC connection, but really what I'm doing is invoking SFTC APIs. And, just like I said that the input stage could be custom and point to just about anything, so can the output stage. We have an example, you would see a video of this on our website where we stream ZOS console message traffic into Splunk. That's not a JDBC operation. That's get the data, transform the data into JSON objects in this case, and then pass that JSON object into a Splunk API. So, that the back end can be, just as open. If you want that data to go to really anything, you can do that. That's why we talk about PropelZ as being so flexible. It's any input source going to virtually any output source. And, the beauty of it is it's not, some of our competitors take a similar approach, but they scatter those pieces on all sorts of different platforms. So you transfer some mainframe data to, Windows or Linux system in the cloud, and then you post-process the data and push it somewhere. What we do is much more straightforward than that. It runs right on your mainframe. It's a zip-eligible workload, so there's no, it's not expensive to do that. And then you have direct connectivity, and of course you have all the resources of your mainframe environment to push that data where you want it to go. Makes it much easier to integrate with production workflows and job scheduling systems, and whatever you need to do to integrate that data. The other thing I'll just mention very quickly is that we also have the ability to do incremental processing. Sometimes the source data we're dealing with is might be terabytes long. And maybe what I'm trying to do is just figure out what's been updated in the last 24 hours so that I can synchronize it to a database somewhere. PropelZ can do that too. So, we don't have to do top to bottom the entire input source. We can examine that data and understand what's changed, what's not changed, and then skip sending the unchanged data out to some type of target. That makes it much simpler to have, I'm going to call it near real-time synchronization between mainframe sources and cloud targets without having to go through complicated change data capture and heavy duty infrastructure. It's very thin infrastructure, very low overhead, doesn't impact the existing applications that are creating this data. So much easier to implement. Some people, and the reason I mentioned that in this particular context is that some of the folks that Dusty and I have spoken to take forever to try and solve that problem. The change data capture products out there are, some of them are very good, but they're very big, very robust, very slow, depending on how much bandwidth you have. They can have all kinds of operational impacts. We spoke to one customer that had been trying to implement this on a small set of files for, no exaggeration, 2 years. And then they finally gave up because they just couldn't make it work properly in their environment. We can give them something very similar to that. It's not, and to be clear, it's not true real-time uh, high integrity. I update this file, and before that update is finished, it's updated in 10 other places. It's not that. It's asynchronous. So you update what you need to update, and maybe a few seconds later, everything is synchronized for you. But in most cases, that's good enough. And if it saves you from all of that other expensive infrastructure, it's a great approach for that kind of thing. Anyway, I'm off topic here, Dusty.
No,
I
no, that was
apologize.
perfect. I wanted to dive into that a little bit too, Vince, because I think one of the magic things, I'm gonna toot your horn, right, as the father of this product is, um, one of the secrets, particularly on VSAM, right, that we come across a lot. We talked about some of the other inputs, but VSAM in particular, the automation in bringing that data in, as well as that the incremental updates that you can do in your online window, every second, every 5 seconds, whatever frequency you want, and with direct access. So it takes a lot of steps out of that process that we see, right, Vince? We've just seen, setting aside that change data capture one in particular, we've seen a lot of other ones that take a lot of, they're staging data, they're staging files, they're, depending on where they're doing the transformation. Or they're waiting weeks, right, to analyze changes in copybooks that we completely automate. So there's a lot of simplification and benefit to having PropelZ sit on the mainframe. And again, there's zero code on the target side, right, in the cloud or your distributed environment. So Vince, you want to just talk a little bit about one of the other more popular use cases which is kind of tape data. That one keeps coming up. People retiring mainframes or just wanting to get off of, magnetic media, or saving money, having additional backup copies. Can you just talk a little bit about that from the PropelZ perspective?
Yeah, we do hear this one a lot, and it's often exactly that. You've got a VTL, virtual tape library, and when you sit down and look at the cost of that environment, you may have, for fault tolerance, you may have one in your data center, one in a remote site. You might have dedicated communications facilities there. It takes human time and effort to manage all of this. So when you actually look at what it costs to manage that storage, it can be pretty expensive. So a lot of customers who have that kind of environment have been talking to us about, could I just go straight to cloud with that stuff? And going straight to cloud is actually the easy part. The question is, what do you do with all of your existing data? You may have literally millions of existing files in that environment that you want to decommission. So, just the migration of that sometimes is a serious problem. So, this is where PropelZ comes in, and the extra dimension here is purely just the scale of the number of files that we're dealing with. So, what we've done is we've done a little customization of PropelZ here, so that instead of, I described the input sources before, but instead of the input source just being a single file, we have a way to go get an inventory of the input data, which, generally that, in the case of the tape libraries that we're talking about, this is one of the other challenges. That inventory could come from a lot of different places. It could be in your ZOS system catalog. It could be in a tape management product like CA1 or IBM's RMM product. I mean, and so that's really the extra level here. We know how to talk to all of those management systems, get the inventory of here's everything in that environment that I want to migrate. And then we can drive PropelZ in a massively parallel way. So, if you had a million files to move or a million tapes to move, whatever you want to think about it as, what we would do is we might say, you know what, based on the amount of network bandwidth you have, we can do, let's say 100 instances of PropelZ all running concurrently. And that might run, much, much faster than would otherwise be the case. You can also, as Dusty described it, you can also, if you have this kind of environment, you probably really care about fault tolerance and replication and all of that. So again, all of those things come into play here. You might say, I want a copy of my data in the Amazon cloud and in the Microsoft cloud, or whatever makes sense to you, or on a on-prem device in your data center with the secondary copy going to the cloud, or whatever combinations you want to achieve, work that way. So this is kind of an easy way of leveraging PropelZ in a way that gets you lots of parallelism and good integration with what could be a vast amount of files that need to be moved. I mean, you could do it by hand with FTP or file transfer program of some sort. The problem is, how would you know what files? How would you find them? How would you do that in an orderly way so that it doesn't end up taking you 3 years to move all of that data around? PropelZ, again, there's no magic in the universe. Ultimately, the limitation is going to be bandwidth. How much network capacity do you have? But these days, a lot of, especially the large customers who would have things like virtual tape libraries probably have pretty massive amounts of bandwidth. And, we think it's possible to do, a pretty compelling amount of storage over that, very, very quickly. And in this case, we're doing parallel PropelZ, if you will. So yeah, and there are probably other examples of that. Backups, for instance, where you might want to stream that data to multiple places concurrently, or instead of one big backup, maybe you run 50 different batch jobs, or however you do it, and you want them all kind of running in a multi-threaded way, either all going to the same place with different files, or different database tables, whatever you're targeting there, or multiple providers. So yeah, lots of options there, and we'd be happy to. I think I'll just mention this. Maybe tooting our horn a little bit is that I think one of the things that we bring to the picture is we all have quite a bit of mainframe experience. We know what works and what doesn't work. So it's not just here's the software, go figure it out. It's we're happy to design kind of a end-to-end solution for folks and make sure that we end up in something we know is going to work and can prove it's going to work before you spend months or years trying to cobble it together yourself.
Thanks, Vince. So, Vince, we talked a little bit about this particular use case. I don't know if there's anything else we need to say about it. Just that you can stream, SMS data, console messages, other messages or alerts, and that's essentially real time. Vince, I guess the other one that comes up is we get asked a lot about just storing SMF records as well, right? So, not a real-time stream, but just a backup to get that off of, more expensive storage. So, like the real-time stream, we can put that data into a database as a blob or even transform it potentially as well. So I think that's maybe another use case that we didn't talk about specifically. I think we've talked a lot about these benefits as we went. Zip eligible workload, 90+% is offloaded into zips if you have those available. I will talk a little bit about the demos here, and just so there's a demo online that is a large complex VSAM file. So Vince, you take it from install to extracting that to, I believe it's a MySQL database, and then presenting that data in Tableau, right, within an hour. And I just want to talk a little bit about that because it really demonstrates the ease of use and implementation of PropelZ. And so, this is not the weeks and months and years. This is hours and days, depending on how many you're implementing or how much how many drivers you're implementing as well. So very, very powerful to get to that data in a very quick fashion. And then the other demo that's available on our website or our YouTube channel is the other one that Vince referenced with live streaming data into Splunk as well. Okay, I think we covered most of these use cases too, but see if there, yeah, I mean, populating data lakes, populating AI platforms, that's more of the target base. We've talked a lot about the source space stuff, so let's keep moving here. I did want to talk a little bit about pricing because we don't want to scare people. This has a lot of power and capability and ease of use, but it's still a very economical product. So we just charge a flat $50,000 per year. So in that tape scenario that Vince was talking about, if you need 100 copies churning away on multiple environments or multiple LPARs or Sysplexes even, it's still $50,000 per year for that enterprise. So that's a really big value, especially when you think about the ease of implementation, use, and the labor savings that you have around PropelZ. And that does come with that $50,000 does come with the drivers that we mentioned. Again, we'll test and deploy additional drivers, typically 5 to 15,000, depending on the driver. There's a couple quirks out there in the JDBC world that we know about that may take just on the upper end of that, but overall, it's pretty inexpensive to have us test and ship an additional driver for you. Okay, I'm going to pause there for any other Q&A that might be available. You can ask that in the Q&A or the chat. I'll look at both. While we're waiting for that, I'll just mention, so PropelZ is one of 3 products, and across these 3 products, we can handle just about every mainframe data integration need that you would have. So Lozen is real-time read-write access. So it takes away all of that event-based architecture, change data capture needs, and your mainframe data remains the system of record, and you just have real-time read-write access from a non-mainframe application or source. ZAC is a very powerful storage and tool and data access tool. So this is data sharing to the mainframe. So you can use cloud as either virtual tape, virtual disk, both at the same time. You can multiplex that, or get access to other data sources off the mainframe, like Workday data or Salesforce data, and easily integrate that into the mainframe. There's a whole ton of other use cases for ZAC as well, and you can find those deep dives into on our website as well. I will just say, listen, we do have some exciting product announcements coming up. So if you're interested in what that is, just kind of monitor our website or our webinar schedule, and you may see that in the near future. And that's something we're pretty excited about, and kind of rounds out this family almost completely, right? There's very, very few use cases that we can't handle. So the one question I had, Vince, was, we talked a lot about mainframe data sources, but in some cases, we can actually use PropelZ on the mainframe to, whoops, going back to this architecture page, we can use PropelZ on the mainframe to ingest non-mainframe files as well, or databases. Is that right?
Yeah, no, and there are many ways that could be done. Very built in, where you might specify the name of the file. You can give us a URL, and essentially we'll do a file transfer to access that data, and then that becomes the input to Propel. So that's all built in to the system. If you wanted to do something more than that, one of the other things we can do is JDBC input query. I mean, we usually talk about JDBC to get to the target, but we can also use JDBC to get to the source. So, let's say you had a Microsoft SQL Server database, either sitting in your data center in the cloud somewhere, and you wanted to take the contents of a table and put it in, let's say, mainframe DB2. We absolutely can do that. And in that case, what's very interesting about it is that because we're talking to a database, it can tell us what those records look like. You don't need to describe your data with any type of metadata. We derive that automatically from the tables that we reference. So, that's a possibility too. And even beyond that, if you wanted to, I don't know, call a Google API or, whatever it is, get a pile of data and pass that into PropelZ, you can do that too with, just a little bit of scripting for that type of thing. So, yeah, open-ended, when we say that the targets are open-ended, it doesn't have to be just mainframe targets. PropelZ is still running on the mainframe, at least today, but it really could reference data, really anywhere you can get it into your mainframe using just about any technique.
All right, thanks, Vince. I had one other question that was submitted, but I don't see that person on, so we'll just follow up with that. That's kind of off topic for today. We got a like I mentioned, we got a ton of other resources. We have blogs on just about every aspect of use cases, security, those types of things around all of our products. The demos that are available for each of our products, check those out. And then, uh, yeah, I would encourage you to listen to our podcast as well. We have some really great guests. We also just do the audio version of all of our webinars as a podcast, so you can listen to that. That podcast is called Skyward Data. It's on all the podcast platforms, Spotify, Intune, um, Apple Podcasts, etc. So just Skyward Data is that what that podcast is called. All right, that's our webinar for today. We'd happy to do any other deep dives or follow-ups or wacky use cases. We love talking about those. You can reach out to us at hello@virtualzcomputing.com or just reach out to us on our website as well. All right, that's it for today. Take care, everyone, and we'll catch you on the next one.
Great. Thanks, Dusty.
Bye, Vince.